So let me. So good everybody. I'm going to be running this lab with you guys. Web Server Attack 1. So it's a premium room, and the aim of this is to enumerate and identify misconfiguration across Apache Nginx, Node, and Python HTTP server. So the first thing I would love us to do is I think we should first start our machine. So I've restarted my attack machine. So I'll start the target machine also. So basically we just want to understand. Okay, I have some machines done. I should terminate this. Let's see. So the machine is turning on. So first of all, what is a server? Let's understand what a server is. So the introduction, during a penetration test, you will most likely run into at least one server. Sometimes it could be Apache, sometimes it could be Nginx, sometimes probably not Python, HTTP server, but mostly Apache, Nginx, and Node.js. So sometimes they could be misconfigured. So your work as a penetration tester is to get this misconfiguration and see what it leads to. So this room focuses on reconnaissance and misconfiguration identification phases of web application testing. So we have different web applications: Apache, Python, built-in HTTP server, a Node.js Express application, and Nginx. Okay. So the room of the lab is mostly for misconfiguration identification. We should not be running exploit on the server, like we should not get shells, remote code execution, and no privilege escalation. The goal is just to build a reconnaissance skill on web servers. Okay, so there are some prerequisites you need to take, like the web security essentials, Linux CLI, and networking essentials. If you have not taken that, please jump into the rooms and take it, because we'll need that in this lab. So let's continue. Let's get into it. So identifying the web server. Okay. So to identify the web server, so basically we need to know the web server that we're dealing with, what kind of web server. Then from there we can tailor our attacks to it, or reconnaissance to it. So we need to know what we're actually dealing with. So that's why we're going to try enumerating directory. I just want to try. So what we know about it, we can try enumerating directories and testing inputs, right? Okay. So the first thing I want us to do, that we're going to be doing, is getting the server response header. So we're going to be using the call command. So basically, we're going to use the call command. The -s is to suppress, the -i is to show the request only, and this is our web app. Basically, this is the IP address of our web application. This is the URL. So let's do that. First of all, as that has loaded, that both of them are started, I would love to connect to it. So I think I'm connected to the machine via SSH, so you could just do that. So the first thing I'm going to do is the curl. So this is the target IP address, and the port is port 80. So that is HTTP. So let's take this. So basically what we're trying to do here, we're trying to reach out to the server on port 80. So let's look at this. So we notice that the server that is being given to us is Apache 2.4.58. Now, when we say this kind of thing, it gives we say this kind of thing that we have been able to enumerate the server being used and the version. The next thing I think you should do is always take this server version and check CVEs. Basically, CVEs are critical vulnerabilities and exposures associated with this version of the server. So from there, we can now know if the server has any, if it's it has any vulnerability that we could exploit, or anything that we use to get into it. But for just this lab, I'm not going to be going into that. So this is how we enumerate the server version. Okay. So look at it right here. So look at the server header tells us the software version outright, and developers can block this. They can block this. Some applications you test it, it's blocked. You will not be able to see it. So not every server exposes this much detail. A hardened deployment might show aperture or suppress the header entirely, but the default configuration on the Ubuntu server leaves the information visible. Okay, so here's is how this is just mapping of the ports and servers. So basically, we're running Apache on port 80. We're running Python on port. That's TryHackMe is running them on it on port 8000. This Node.js is running on port 3000, and Nginx is running on port 8080. So this is how their default header looks like, something like this. So let's test that out. Okay. So basically, how you notice this Node.js is the expired header. So sometimes framework add the expired header that reviews the application layer behind the server. Express sets this by default. So basically, this output doesn't really tell us much, but sometimes if the application is not properly it's not properly done well, it could tell us a lot more. Like the let me see. Okay, it didn't say that. It could tell us a lot more. Let me just leave it at that. So browser developers tools. So we can use the browser developers tools to also enumerate. So you notice if you are working in browser, the network tab provides the same header information on this port 8080. So let's copy this and let me go into it. So okay, I'm going to use Ctrl Shift I to get into this, and then on my network tools, let me refresh this page. Notice, where is it? Okay, look at it. Expired Express. So we know that this application is using Node.js as the server. So we could now tailor our information gathering to that. Okay. So we could also send requests to the server. So when we use the -si, we're basically send a head request which returns the header only and nobody, okay, to default error pages, and need a get request switch to -s without the -i. Okay, so if you want to see default error pages, you need a get request, so you just switch to -s without the I. So let's look at what this does. So I'm just going to copy it from here. So we're working with ports. Well, we're working with. So they said when we request a path that doesn't exist, Python. Okay. So we're working Python gives the plaintext Nginx. Okay, so let's see what we have. Let's try each endpoint. Let's see what it gives us. So I'll just use port 80 first. So it gives us a 44 basically not found. So the requested URL cannot be found. Let's try an 8000. So look at how the error message looks like. So it sends 8000 is running I think Python, right? 8000 is running what? Yes, Python. So this is how the header looks like. Basically it's the same but not. Okay, so this is how it looks for Node. Okay, can get non-existent page XY. So you can also use this to also know which kind of server is being run, whether it's Python, Nginx, or Apache. So in case they suppress the header and you can't see it, you can use the errors. You can use this error to know which one is which. Okay. So the first question says, what type of server header returns when the returns for the Python HTTP server running on port 8080? So we're checking for port 8080. So we could just, let me clear screen, go back to this, let me grab it from here. So I'm working with this, and Python is running on port 8000, right? So we could just do curl-si 8000. So by doing this, pressing enter, you notice that we have the server to be simple HTTP, blah 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 blah. This is Python, so we just copy this and then we put it as our flag. So we just put this here and we get it. So which HTTP header reveals the application framework running on port 3000? So on port 3000, is the X powered by, which tells us that it's running on Node. So Node.js. So that is it. Express by. So what web server is running on port 8080? We have it up here. It's Nginx 8080 Nginx. Or you can also test it with the curl command. So now this is going to the Python HTTP header. Okay. So to start the Python HTTP, to start a Python server, it's really easy. So we could just do this python -m http.server 8080. So let's see. Okay, press command from this, blah blah blah, system of internal connection close by. What port are we running this stuff on? Okay, on port 8000. I think maybe 8080 is binded to something already. Not letting me play this. I think my history has like a little problem. I'm connected. So if I want to access this port, I could just, okay, I'm connected on the VPN, so I can do this from my main machine. So I could do curl I, then connect to the target machine. Okay, we're running it on the virtual on the attack box, so it should be there. HTTP port 8000. So you notice immediately we get, it sends the request, it shows on the server receives it. Okay, so that's how Python servers work. Okay, so directory listing. But the problem with Python servers I need to mention is that it shows every single thing in that directory. So for example, we are on this directory. Once we host the server on the home directory, every single thing is served on that server, meaning that we can access every single thing on that server. For example, I'm hosting it right now on this home directory. If I go to my browser and do this 8000, notice that it shows every single thing on my home directory. So it serves every single thing on my host directory. So if you look at my host directory, let me stop this. Every single thing is served there. From CTF viewer, everything is served here. Okay, so it's not really safe to do that, because you could show every single directory, that is your environment, environment data, every single thing, your HC access, all of them could be listing all this, and it's not really good. Okay, so directory listing. So when no index.html file is present, the Python file generates a HTML page listing every file, generates a HTML page listing every file it can see. Browse to the roots. Okay, we should browse to this and now browser. So remember, we have Python running on our Python server running on port 8000 on our target machine. So I'm just going to take this and go back to this, and I'll just curl -s to this. And notice something. Look at this HTML document. Look at this. It said directly listing for this. We're getting this link. .env, .backup, .this, .no. So basically, it's listing everything in the directory. So let me just try dot config. Let's see what's going on. Stroke. Let me do notes. Txt. Okay, so notes.txt. I think it prints out the content. Okay, not found. Not. What just happened? Notes.txt. Let me print this out first. Okay, env. This. Notes.txt. So I think we can copy every single thing here. So let's do that. Okay, so they went to the web app, they accessed it from here. So note.txt should be accessible. Let's try this. Notes.txt. Am I putting it in the right place? Oh, it's not supposed to be like this. Look at sorry, mistake. I was there, and I did it correctly before one time, the other time, and notes.txt. Okay, look at notes.txt. To remove this before going live, blah blah blah. Admin create admin 1, admin 1 to 3 staging blah. So let's check it for the environment variables. So this is, so notice this. Look at this. It gives a secret key, dev secret key, do not use, database URL, Postgres, blah blah blah, blah blah blah, debug equals true. Okay, so these are our environment variables. So we could save this somewhere because I think we'll need it. So, but let's keep looking at this. So downloading and inspecting the archives. So remember we had a .zip file, so let's download it. Okay, so we could just easily download it by curl -s this guy. Wait, let me see what this gives. Okay, okay, so it's the backup file we're trying to download. So okay, so we're trying to download the backup file, backup.zip. The -o is to download, and then we'll save it to a file called backup.zip. So enter, it's done. So I can ls for you to see that. Where is it? My god, I can't see it. I can't see it. Okay, backup.zip. So I can't see. So I'm going to just cd into it. Oh, it's a zip file. Oh, I'm so sorry. So let me unzip it first. So there are two contents. Okay, there's just one content. Dump database dump.sql. So see, let's cut the database dump.sql. Okay, so we have SQL. Okay, the database dump for the staging environment. Okay, so it has every single thing here. Okay, see flag. Let me just copy this. Copied, and I'm going to go. So we have a flag. Okay, so we just put the flag here. So the Python HTTP server is realistic. The Python HTTP is a realistic finding because it requires no exploitation. There is no vulnerability to trigger. The server is functioning exactly as designed. The most configuration is that it is running in a location where it should not be in. So it's running in a location where the environment variables are, where the backup contents are. So it should not be running in such kind of location. So it should run in a location where the assets inside that has to be served are not um and are not supposed to be confidential only to the developers or the company having or the company that owns the web application. So it should be on the deployment or deployment production stage. So it should not contain sensitive information. So the Python server is running with, okay, I've read that. So documenting this in a real engagement means explaining not just that the server exists, but also what it exposes and what attackers could do with this information. Okay. So the what database password is stored in the environment file served on Python HTTP server. So we can check this out by checking. You can just check this out by let's call that request again. Get it. Okay, so I think it's on so the question asks us to what database password is stored in the environment variable. So okay, we can just for the environment variable dot env, and we have the secret key, we have the database URL. So if you look at this Postgres // web app, this is the password at localhost. So we copy this and then we paste it here. So that's the answer. Okay, so the next is Apache. Okay, let me just scroll up. So Apache is the most used web server for deployment, which means that it appears nearly in every engagement that touches web infrastructure. Its default Ubuntu configuration leaves several things enabled that testers regularly find and report. The three most common are directly listing on specific paths, that is the server status module, and backup files sitting in the document root. Okay, so first of all, let's get the version disclosure. So let's do this. Let me just open the. Okay, this is okay. Let me close this collapse down. Okay. So I could do curl -si, and we're trying to curl the target machine. So the web app running on the target machine. So just copy this and I'll paste it. Right. So when we run this, we have a whole bunch of stuff. So we can easily get the server here, or we could grep for it in case the content is a lot. We could just grep -i to for nonsense case sensitivity, and then we're looking for server. So it picks up this server Apache 2.4.58. So if we just take this and search this on like an exploit data, a vulnerability database that has like CVEs and stuff, so you could get maybe a vulnerability that exists on that particular server, that particular version of Apache. Okay, so directory listing. Apache's options index directives tells the server to display a file listing when the directory does not have an index.html or similar default file. This is sometimes enabled intentionally for internal file shared directories and accidentally left on paths that contain sensitive data. So sometimes they forget to stop sharing internal files because they should do this so that it can easily for developers to just get this information. So sometimes they leave it and attackers can be able to list the directories. So it's really bad. So first of all, let's go into this web page. Let's see what's going on there. Now notice this. We have two things. We have the employee CV, we have the internal notes. So let me see what this internal notes look interesting. So we already have a flag. Okay, so let's leave that for now. Let's go back to our employee CSV. So this is downloaded. Let's see what's inside. Seems that the previous session did not end. Normally they want to. Yep. Okay. ID. Okay, just the names. I don't think it's not looking interesting. So let's go back. So looking at, let me go back to my. Okay, so you see the HTML page with the title index of files, listing the files available in that directory. Apache directory listing includes file names, file size, and last modified dates, which gives a clear picture of what is there before you decide what to receive. Okay, so we have the file name, the date, the time, and the file size. So the next is the MOD status page. So Apache includes a built-in page powered by MOD status module, which when correctly configured, it's available only to localhosts. Okay, so when misconfigured with require all guaranteed, it's accessible from any IP address. You can access it via basically the endpoint server dot status at server status. So let's go there and see what is actually going on. So it's just like a document that tells us what the basically every single information documentation about the server. So let's run this. Let's see. Okay, so it tells us the version, tells us the build, tells us query time, uptime. That's run for 38 minutes. The CPU usage it shows us the requests that have been coming to it. So just imagine an attacker can get this information from a server. They already know what every user is doing. They already know, and they already know what people are saying to the server, which is not ideal. So most server is enabled by default on Apache package and ships with the required local restriction in this. That too long. However, it requires all guaranteed directive anywhere in the virtual host configuration slightly overrides the restriction, exposing server status to all IP without ever touching the module config. Always check server status even on servers that appear to be using the default settings. Okay, so you could be using the default settings, but it could still be showing this requiring all granted, which allows us to pull the mod status page. Okay, so finding unlinked files with GoBuster. So basically, GoBuster is just used for brute forcing, maybe directories and the rest. So we're going to be using in this case to brute force directories, I think. So okay, so let's look at it. Okay, So dash U is the target URL, dash W is the word list, dash X tells GoBuster to append this to the end of whatever it's doing. So look at the command. So GoBuster, we're doing a directory brute force. We're using the dash U to specify the URL, which is this, dash W to specify the word list, which is this, dash X to specify the extensions that we're going to add to that to each of them. So basically things inside this are like config, a lot of other things. Let's check it out. Let's see what's actually inside the part. So let's just copy this. Sorry, thought I was on. I did the Control Shift. So just Control C. Okay, so let's just take this here, put it down here. What is inside this directory? I'm sorry, let me just I'm just curious. So let me see what's actually inside it. Inside this file. Oh, that's sexy, okay? So notice it's like this. So once we do the full command, it adds things like let me get the full command. So basically this dash X is to add extensions. So whatever it has, whatever is in the command.txt file, it will add this. Maybe it will add something like that dot back dot HTML, stuff like that. So that's what we're going to be working with. So let's fill in the target IP address. Okay, so the target IP address, we're going to be getting it from here. Go here, we get the target IP address. Let's just copy it, take it down here. No, not this guy, sorry, this one, and then I'll just put it down, put it there. Okay, so everything looks good. Let's send it. Okay, look at this. We get our results. We get, so look at HT password.txt status 43. I mean, we're forbidding. But look at this backup.bak. We get it 200. This one we get redirected to the files. Same with this, we get it 200 for index.html, and then index for a 200 for server.status. So we could start, anyone that we're curious with, we can start checking them out first. So I would love to see what's actually inside. Use the dash si. So okay, notice this. Now notice what we have. Okay, it's really Apache file. So finally, I think the problem was from my VPN. So I can see the two files, and if I check the internal notes, I get the flag thm Apache directory listing, and from there I can copy it, and I'll come over here and I'll paste it. I've gotten that. So the next one is Node.js um, server. So Node.js behaves differently from Apache and HTTP. Oh, sorry. Okay, it behaves differently from Apache and HTTP. So how does it actually do that? So it's not serving static files from a configured document root. They are running application code, and that code decides what to return to every request. So unlike Nginx, sorry, I say Nginx, Apache and Python, that serves whatever, basically serves assets from a file. Um, Node.js is different. What it does is that you give it the configuration is basically in sort of code. So you give it like application logic, and that's what you use in configuring the server. Okay, so it's flexible. That flexibility is powerful, but it's also where many mistakes occur. Okay, so let's test out this node. We can do this by doing this. Let me just close this. Over there, I had to paste this right here. So after copying that, I need to paste it and try. Okay, yeah, copy it. Okay. So when I run this, notice you get the express. So it means that we're using Node. Okay. So reading the application version. So we could just use the -s and it will give us status. Okay, all of this. So let me just show you. We have the press already there. So it's going to suppress everything else. So we have status. Okay, app, this version, this. Okay. So triggering verbose error. So there are two modes of in Node, or the Node env. We have the production and we have the development mode, right? So the production mode is the mode you want it to be in when you have finally produced this product. So you want to let everybody use it. The kind of errors you should be giving like generic errors. You should be giving errors that that won't make that does not like technical errors that the developer will need to solve a problem. So development errors are the kind of errors that you want as a developer when developing the software, so that you actually understand what you're actually doing. You actually understand the technical details of what's actually failing in your server. So you want it at production. You want the node env to be set to production when you're allowing users to use this thing at the final stage. Okay, but sometimes even when they set it at production, developers still write logic um to let some of this environment or some of this essential data leak. So they are setting that production, but they still make mistakes and write in node logic. Remember, we use code to carry out the configuration. So you can still write the errors, or write the verbose errors in the logic. So it still prints out technical errors that an attacker can use to get more information about your infrastructure. So but developers often write their own error handlers, and these custom handlers expose stack traces regardless of node env, which could be set to production. So in the attached VM web application, use a custom error handler. The detailed JSON response you set is not part of the express behavior. Okay, so we need node equals to this, and you need to also make sure that your logic is not giving out some um, some essential verbose error that can give an attacker some ideas. Okay, so let's do this. Let's quarrel this endpoint, these API users. Okay. So I didn't paste, I didn't copy that. I'm not really used to using this. Um I'm just used to using my own system, not this one. Um, is that the same thing I just did? No, probably this. Put it here. What is going on? Oh my god. So I think I just have to type it. Okay, so we're reaching out to API users. So let me just get to the API users. I just have to do that manually. Let me not waste our time here. So let me just keep it on suppress mode. And okay, so let me reach out to this first. Okay, notice it gives us this error that looks jargon, that looks like it's jargon. So let me just use like pretty print. Okay, good. So we have, can now read it properly. So notice this error connect blah 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 to this stack error. Doesn't really make sense, but look at this last part. The query that is using an SQL database. So we have select from users. So now we have been able to tell that, okay, first of all, this is SQL. So the attacker can map attacks to that. One. Second, it knows exactly that what is happening on the API users is that it's getting um every single column from getting every single thing from the users table. Okay. So the attacker can also map that out, which could give him some ideas or give them some ideas. So okay, a 500 internet error from an endpoint is worth investigating further. In development mode, the response often contains the error, stack trace, and context about what the application was trying and when it failed. Exactly what we got here. So it was trying a connection refused on this. So it's giving us detailed explanation even with query, which this should really be seen by the developers. So it also reveals internal file names, modules, and sometimes database query that triggered the failure, like in this case. Each of these details tells you something about the application internals that a simple status code does not. Okay? So enumerating routes via debug endpoints. One of the most useful ways or useful things a misconfigured Express application can do is to tell you all of its routes. Developers sometimes build a debug endpoint that lists every register route for convenience during development, then forget to remove it before going live. Okay, so let's test this out. So the API route is the endpoint where we're going to be checking stuff out. So I'm going to curl this. Okay. I'll just do this manually. I'm not ready to. API routes. Okay, so look at what we get. We'll be able to get the method get path this. We're going to get one. We have one path. We have the API users. We have the API routes. We have the API debug environment. So I'm very interested in this. I want to see what's inside this. So I can call. Let me use the formal request. API debug env, and look at what I got. Node environment development. So it's still in development mode. Environment. So the database password, I was able to pull it out. Look at all of this. So it's messed up. Just don't leave your node environment on development. So always move it to production, and always remember not to still mistakenly in your logic put verbose errors that give us technical information about the system. Okay, so exposed environment variables. So in this case, we're able to pull it out. This is exactly the same thing we did. So we'll be able to pull that out. So if the response includes database password, secret key, or similar fields, document them. The node environment value is also telling. Node environment equals to development on a production server is a signal that the application was developed without proper hardening. Yep, that's true. So static file serving. Okay, static file serving. So Express applications commonly use express.static middleware to serve front-end assets like JavaScript files, style, sheets, and configuration. The static file route, if it exists, serves everything in the directory. Client-side JavaScript finds files, sometimes contain API endpoint URL, internal host names, or debug flags embedded as constants. Once you know the routes from the API routes endpoint, check what is being served statically. Okay, so let's check what's actually being served statically. So let's check that one route again. Let's see whether we have anything interesting from there. Okay, we have the route. Okay, so okay, let's check this out. Oh, forgot that. So I'll just do this static what? Static config.js. So this is to see everything. Static config.js. So let's see. Client side configuration. I've forgotten something. So inside this express static application usually use express static to host or to serve the front end assets. So we'll be able to find the flag hidden inside. So I think that's one thing you can grab. Okay. So note express static silently returns a 4 for dot file starting with dot by default. Let's try that out. File starting with dot. Let's try .env. Let me try something. Let's not try this. Cannot get static. Okay. No, it's not here. No, just leave that. Okay. Putting it all together, take a step back and look at what we just did. We started with header inspection to confirm the framework, then triggered an error to see the application leak in failure mode, then used the debug endpoint to enumerate routes, then checked for credential exposure in environment variables, and finally followed the routes list to the static files where the flag lives. This pattern works because each step narrows the scope for the next one. Header tells you the framework, errors tells you the internals, debug endpoint tells you the routes, static files tell you what developers assume and what developers tell you what the developers assumed was safe to expose. Okay, so the node environment variable have as what debug endpoint, that is the development, and the flag that we got before, we just paste it here. Okay, so let's go into nginx server. So after Apache and Node, the Nginx instruction investigation follows the same template, but it has its own configuration vocabulary. The categories of misconfiguration, version disclosure, directory listing, and exposed status page appear again, but the specific directories and paths differ. Okay, so first of all, we could just take this to for information gathering to for version disclosure. So copy this something like this. By using port 8080, not like I can even copy it. So let me just do it like this. 8080. So we have welcome internal use only. So I'm going to give it this. So it gives me the server nginx, so I could grep for just server like what they did. So I get the server nginx. Okay. So nginx includes its version in the server header by default. Unlike Apache, we use server token directive to control this. Nginx uses server tokens. So the default is on. Default is on. That exposes the version. Knowing the exact version is useful when checking Nginx change logs for security fixes or when building an engagement report. Okay. So the server token directive controls both the server header and the version string in default error pages simultaneously. Setting server token off suppresses the version. Okay, that's good to know. From both places at once. If the server header is suppressed, requesting a non-existent path will confirm whether server token is truly off or just partially configured. So, okay, we can use this server to we can use like an error. Basically, get requesting a directory that we are sure that it does not exist. We can use it to tell whether the version whether the server token is off or it's on. So basically, if the server token is on, suppress. If its server token is on, it doesn't suppress the version. While if it's off, it suppresses the version. So let's test this out with a directory that definitely doesn't exist. Okay. Always make that mistake. It's okay, not found. Let me get the full. Okay, so look at this 44 not found. So this is kind of error we get, and we get the version number. This is telling us immediately that the server token is turned on, so we can see the version. So there's version disclosure. Okay. Directory listing with auto index. So Nginx does not enable directory listing by default. When a developer wants to expose a directory listing, they add auto index to a location block in the configuration. So look at this. So the location is the files directory, and once auto index is turned on, we can list that directory. So okay, let's look at this. So it's turned on. So they say the documented nginx configuration option, and okay, the document this is documented nginx configuration option and appears in legitimate file sharing setup. The misconfiguration is using it on a path that contains sensitive files or leaving it enabled on a production server without access controls. Okay, so let's visit this application. Let's see. Oh, not here. Let me visit it on this guy. Let me see whether this works finally work. Nah. Doesn't. So let me see what I need to actually visit. Okay, the files. 40.129, 170. Okay. 173.4, right? Okay. Now I'm visiting this, but I'm visiting files. Okay, so these are the content I've seen this before. Oh, let me add an extra time and an extra hour. Okay. So, oh, this is port 8080. That was a different port. No wonder we saw the same thing. 8080. Good. So, passing files or index of files. So, let me check this. This is looking interesting. Server config, the txt. This nice. I don't know, every single time I just start on this one. On the last one, it just shows me like a flag. So there's a flag here. So let's check the other ones. Let's check the backup. Maybe I don't think we'll be able to. We have to unzip this and unarchive it. Type word unarchive. I don't really know. So we got a sudo password, SSH password, or what? Okay, SSH key location, sudo password. Okay, these are all sensitive information that should not be let out. So just because it's directory listing set by auto index, so always look out for this. Make sure it's turned off. Okay, as long as it's in production stage. So the Nginx endpoint status endpoint. So Nginx stop status module exposes real-time connection metrics. Basically, just like the other one for Aperture. What is it called again? I need to check this out. I think it's what's the name again? Mob status. Okay. Let's see whether it's actually the same thing. Let's read it again. Well, expresses real-time connection metrics at a configurable URL. The secure configuration restricts access to localhost only. Okay, restrict access to localhost only. The configuration version allows access from any IP address. So basically, to get this real-time connection, you need to be localhost, but that is for a protected system. But for a misconfigured version, it allows you to access from any IP address. So basically, if you're not in net, if you're not localhost, you can access the real-time connection metrics, which is basically stop status. Okay, so look at the logic here. So location, nginx status, stop status, allow all. So allows should be only this, should be allowed this, that is 127.0.0.1, which is our loopback address, and deny everything else. But in this case, we're allowing all, which just shows that it's misconfigured. Okay, so let's get into that real-time connection since it's misconfigured. Well, forget every single time. And I can't just paste. Sorry. Nginx server, right? Status. Okay, so look at this. Active connection 1, server accepts handled request 771, reading 0, writing 1, waiting 1. So this is telling us information about the connections, the server, what their server accepts. Their server accepts handled connection 771. Okay, so the output format is compact and uses unlabeled numbers on the second line, which can be discussed. Yeah, which can be disorienting the first time you see it. Yeah, that is this guy. Think. So let's look at it. See, the three numbers on the second line are in order: total accepted connection. So he accepted 7, that is total accepted connection. Total handled connection, which is also 7, and total requests since the server started. So we had 11. So the third line breaks down currently active connections by state. Let's look at that. Okay, reading, writing, waiting. Okay, while the data is not directly exploitable, it leaks operational information about server load and usage patterns. And one thing attackers love is extra information about your system. So on a real engagement, an exposed Nginx status endpoint is a finding because it confirms the internal monitoring setup and may indicate other monitoring endpoints are similarly exposed. Okay, so putting it all together, the Nginx investigation follows a path and parallel structure to the Apache tags. Check the version header, browse the directories with auto-index enabled, check the status endpoint, the specific path and configuration directive differ, the investigation approach is the same. The Nginx configuration lives in this etc Nginx directory on Ubuntu. If you ever have shell access to a running Nginx, read the site configuration in etc this. This will show you exactly which directories are exposed and what models are enabled. So I think in the web server soon, we're going to be working on how to get remote code execution and shell access to web servers. So what Nginx directive enables directory listing in a location block. I think I'm going too fast. Okay, let me slow down a little bit. So so you could scroll up, and if when you scroll up, you notice what was the question, sorry. So enables directory listing. For directory listing, I think that is auto index. So you can scroll up directory listing auto index. So you just copy that, paste that there, auto index on. So what URL exposes Nginx connection statistics? Okay, Nginx and status endpoint. So basically the URL, a secret URL, the endpoint is the Nginx status, and the flag that we got from this when we went to um we got this guy. Flag was this guy, so we just copied it and we pasted it there. Common misconfiguration across path. Okay, so let's look at this. We have now walked through different web servers, each of its own configuration model and its own set of common mistakes. There are also patterns that appear regardless of what server is running. Two of the most consistent are missing security headers and finding the automated scanner surface quickly. Okay, so security headers allow us to block a lot of attacks by default. Just block them. So, for example, XSS, clickjacking, a lot of other ones also. So let's look at some of the important security headers that we need to have on our HTTP header. So here are some common ones. So we have the X-frame options. Now, what this X-frame options does is that it prevents clickjacking. So clickjacking, it prevents the page from being embedded into another domain, so you can't basically see it there. So what you do is by using same origin. So X content type option prevents meme sniffing. So that is basically preventing the browser from guessing content types. So you just set it to no sniff. Content security policy restricts where scripts, style sheets, and other resources can load from. This is the value. Referral policy controls what is sent in the referral header when navigating to another page. Okay, so strict transport security forces HTTP for subsequent requests. So basically, this one, if you try to use like a HTTP, sorry, forces HTTPS. If you try to use HTTP, it redirects you to like use HTTPS. So it lasts for, I think this, if you calculate this, is a year. So yeah. So audit each server with curl. So let's look at this. Okay, this is bash. So we're seeing for ports in, so this port 80, 8000, that's Apache, um, Python, Nginx. I think this is Nginx and Node. So want to echo port and then passing the port, and we're trying to curl this website, this um endpoint with this port. So port 80, basically no security headers found. So we're using the SI to get the HTTP header. Okay. So let's look at this. So let's run this. Let's run this. Oh, this is long. So it's checking for these headers to see if they are there. Oh no. This is what I don't want. As it's copied now, let me see whether I can just paste it here. Okay, it's working. But if I try putting it here, okay, so sorry, let's go and press Ctrl P. So it's not really working. Okay, I'll go back. So basically, you can just see it from here. Can't really copy it. So no security headers found. You can just try that out. So automated scanning with Nikto. So basically, Nikto is a vulnerability, is a web scanner for misconfiguration, outdated softwares, and the rest. So we use the tool by using Nikto-H. We pass in the URL, and when we pass in no interactive, we're just saying we don't want to interact with it. We just want it to do it completely without human interaction or any interaction. So we could copy this. And let me just write it. Nikto -H. I'm dealing with this guy. Right. For 18. So I'm dealing with 18. So dash no interactive. No interactive. Present that. Oh, I think I wrote something wrong. Nikto-H 18 no interactive. Okay, there's no space for them. No interactive. Okay, it's doing its work. That's not it. Why is it taking so much time? It take this long. Working with 40, right? Okay, it's 4. Wrong IP. So notice what need to pose that for us. So it gives us the server, tells us um it tells us anti-clicking extreme header not present. So basically you can get an attacker can try click jacking. So files, this file directory indexing found might be interesting. Okay, allowed HTTP head get post options. Okay, server status. This reveals aperture information, comments out appropriate line of this, or restrict access to allow hosts. Okay. Okay. So let's look at this. Patterns that apply everywhere. Look back at the first servers. The same categories of misconfiguration appears repeatedly. Version disclosure, all of them have, except node that is partial because it just tells us express sometimes, and sometimes it will tell us like the full details. So it's up to the developer. So directory listing. This one directory listing is in the files. This one is in the root path. This does not have, and nginx files. So export status or debug endpoint. This one is the server status. Python doesn't have. This one is the API debug environment or the API route, and the API route. This one is the nginx server status. Sorry. Sensitive file access. Backup dot back internal nodes. This one is environment nodes.txt backup configure. This one is config.js, and this one is this. So missing security headers is missing all. Is missing all. So the consistent thread is that default configuration prioritizes ease of deployment over security. Version disclosure, discovery listing, and status page are enabled by default for diagnosis purpose. This makes the administrator job easier, removing or restricting them takes deliberate action. In real engagement, finding this pattern does not indicate negligence. It indicates that the default settings were never reviewed. Okay, so what security header when missing allows a page to be embedded in an iframe or another domain. So what a security header allows when not there present allows click jacking. So there's an S frame option, click jacking. Okay, what text does Nikto report when it detects directory indexing on files path? So let's check that out. Directory on files path. It says directory indexing found. So copy that and paste directory indexing file. Okay. Walking through 4 different servers on a machine shows something that is easy to miss when you study each server's type in isolation. The underlying pattern are the same: version disclosure, the directory listing, exposed status page, and security missing security header across Apache, Nginx, Node, and Python for the same reason. Default configuration are permissive. Security requires configuration. Takeaway: response headers are the fastest fingerprinting surface. The server and expired by header review software type and sometimes version before you have made a single request to an actual application path. Python built-in HTTP has no access control of its kind when it appears in engagement, assuming the entire working directory is readable, including dots such as .env. Okay, so you could just so Aperture mode, status, and directory listing are enabled by default on Ubuntu. Stores and requires active configuration to restrict them. Their presence is common and worth checking every Aperture engagement. Okay, so yeah, you can just complete this and you are done with the room. So congratulations, you've done web server attack 1. We are and we are done. um Done.